What is up, math superstars? In this edition of Mr. Peterson Presents, I'm bringing to you Objective 7.15. We are talking about inequalities here. And so our very first step is we're going to talk about some keywords and the symbols that go with them. And so our first sign right here is we have the less than sign. Our next sign, this is called our greater than sign. And then we have the less than or equal to sign. But in word problems, so in some word problems that we'll deal with in future videos, you'll see these couple keywords here that you can just add into your notes. When you see at most or no more than, you'll know that this is also the less than or equal to sign. And then we have the greater than or equal to sign. And so once again, we just have a couple keywords here. So you can pause our video, write that down. We have at least or no less than. And so this is the famous one. You see this one. As soon as you get tall enough to ride, all the big rides at King's Dominion and other amusement parks that you go to, you know that you have to be at least 48 inches or higher to ride certain rides. And this is one that you'll see the most. So we have a couple fill in the blanks here. So any number that makes an inequality true is called a solution of the inequality. And an inequality may have many solutions. So when we talk about the solutions to inequalities, you'll notice that it's going to be multiple numbers. So since the inequality has many solutions, it's often graphed using a number line. So a number line is graphed left to right, so fill in the blanks here, is graphed to show all of the possible solutions that make the inequality true. An open or closed circle is used to show where the solutions begin. Is your fill in the blank. And an arrow pointing either to the left or to the right indicates where the rest of the solutions are located on our number line. So here we're given this inequality. This is x is greater than 1. And so right now, the way this is graphed, it has an open circle on 1. This tells us that 1 is not included in our solution set here, but we know that all the numbers to the right of 1 make this solution set true. So if we were to fill in 2 for x, we can say that 2 is greater than 1. If we filled in 3 for x, 3 is greater than 1. And we can go right down the line. We can also use the decimals, fractions. As long as they are greater than 1, this makes the inequality true. So, but this open circle is used with the greater than and less than symbols. So now we have this inequality. X is less than or equal to -2. So this closed circle on 2, this means that 2 is included in our solution set. And so we know that, -2 is included in our solution set. And so what we can say is that -2 is less than or equal to -2. But we can also say that that's the same true for -3 is less than or equal to -2, and so on and so forth. On our number line, we can use our decimals, fractions, all those good things, but our closed circle is used with the greater than or equal to or the less than or equal to symbol. So we know that the dot tells us if it's included in the solution set or not, and then the arrow tells us all the other possible solutions for x. So now all we're given is we have to graph this inequality here. So p is less than or equal to -1. So the way I graph this is I start -1 in the middle, and then I usually graph a couple numbers to the right, and then a couple numbers to the left. So this is the test to see which way the arrow goes. So since it's less than or equal to, I know that I'm going to have a closed circle on -1. I always start with my circle first, whether it's closed or open. And then to determine which way the arrow goes, I'm going to test both sides of where I graph the circle. So let's start with 0. Is 0, if I filled that in for P, is 0 less than or equal to -1? 0 is greater than, so I'm going to mark that with an X, just to help me out. So is 1 less than or equal to -1? No, that's not true. So let's test -2. Is -2 less than or equal to -1? So that's true. Let's put a little smiley face there. So what about -3? -3 would be less than -1. So for my arrow, I'm going toward the smiley faces here. So I'm going to shade in my arrow going to the left. Let's go ahead and try to graph -5 is greater than y. So I'm going to graph -5 on the number line, and then some numbers to the right, and then some numbers to the left. I know that I have an open circle on -5 since I'm dealing with greater than. And let's go ahead and solve to see which way this arrow is going. So if I started with -4, is -5 greater than -4? Answer is no, so I'm going to put an X there. Help me out. -5 is not greater than -3, but -5 is greater than -6. And -5 is greater than -7. So I'm going to shade in my arrow to the left, going with my smiley faces here, saying that where I'm shading is all the possible solutions. Let's go ahead and graph this one. I have 5 is greater than or equal to 6. So let's go ahead and graph 6 on our number line, 7 and 8, and then 5 and 4. I'm dealing with the closed circle on 6. Now let's figure out which way our arrow is going. Is 7, let's start with 7, is 7 greater than 6? Yep, that's true. What about 8? 8 is greater than 6. Let's test the other side just to make sure. Is 5 greater than 6? Nope, 5 is less than. Same thing with 4. So I'm going to go ahead and fill in my arrow for all the possible solutions for M going to the right. So now we get to solve inequalities. And so this is pretty similar to doing one-step equations, except there might be a little bit of differences here and there. So the differences are when we hit multiplication and division, there's a rule that needs to be followed. And the only other difference is we actually have to graph all the solutions on a number line. So our first step here is we're going to solve for y. And so the same thing we do, we're going to do the inverse operations to get y by itself. So we're left with y. Let's go ahead and bring down our greater than sign, and then we're left with 6. And so what we can do to check to see if we did this right, let's first graph this inequality here. So let's put 6 in the middle, 7 and 8, and then 5 and then 4. So what we can do is we know that we're going to have an open circle on 6. And since it's greater than, we're going to the right. And so to check to see if we did this correctly, let's go ahead and pick one of the possible solutions that is on the shaded part of our number line. So let's go ahead and try 7. So we're checking to see if we did this inequality correctly. So what we do is we go ahead and fill in 7 for y and rewrite our equation, our inequality. We do order operations on the left-hand side. So we're left with 12. And then we bring down our greater than sign is 11. So is this inequality true? 12 is greater than 11. So if that inequality is true, we did our one-step inequality properly. So what about this inequality? We have x plus 9 is less than 13. So what we can do is we can subtract 9 from both sides of our inequality. We bring our x down, we bring our sign down, and then 13 minus 9 gives us 4. So let's go ahead and graph this on our number line. So we know we have an open circle on 4. And our arrow is going to the left because we have x is less than 4 here. So let's go ahead and check that to see if it works. So let's go ahead and fill in a number that is less than 4. So let's try 3. So 3 plus 9 is less than 13. Let's go and do order operations on the left-hand side. 12 is less than 13. We know that inequality statement is true, so we know that we did our one step properly. So now for number 3, we're given this inequality. Negative 21 is greater than or equal to d minus 8. So let's go ahead and do our one step here to get d by itself. So we're going to go ahead and add 8 to both sides of our inequality. We bring our variable down. We bring our inequality sign down, and then let's go ahead and bring down 21 minus 8. It gives us negative 13. Let's go ahead and graph our inequality next. Negative 13, negative 12, negative 11, negative 14, and negative 15. We now have a closed circle on 13, and let's figure out which way our arrow is going here. So is negative 13, is that greater than or equal to negative 12? No. Is negative 13 greater than negative 11? No. So we know that negative 14 is less than negative 13, and then negative 13 is greater than negative 15. So our arrows go into the left here. Then let's go ahead and check to see if we did this inequality correctly. So we were at our original equation. Let's go ahead and fill in negative 14 for d. And let's go ahead and do our order operations here on the right-hand side this time. So negative 14 plus negative 8 is negative 22. So is this inequality true? Negative 21 is greater than negative 22. That means we did this inequality correctly. So what about number 4? Just giving some examples here. We're subtracting 8 from both sides of our inequality. We bring down our inequality sign, and right here, this is the infamous negative 10. It is not 6, it is not negative 6. We need to make sure we subtract those two integers correctly. So now let's go ahead and label some numbers on our number line. We have an open circle on negative 10, and since it's less than, it is going to the left. Now let's go ahead and rewrite this inequality here. Let's go ahead and substitute a value that is in the shaded part. So let's substitute negative 11. Let's go ahead and subtract on the left-hand side. Negative 3 is less than negative 2. So we did this inequality correctly. So now this is where it gets a little tricky. So we got some fill in the blanks to help you out here. And so when you multiply or divide each side by the same positive number, the inequality sign stays the same. But when you multiply or divide each side by the same, this is where the difference is, negative number. And if you need to make a note, it is only with the negative numbers. The inequality symbol must be flipped. So of course, we're going to give you some examples of what this looks like. So let's do a positive example here. So we have 9x is less than or equal to negative 54. To get x by itself, we're going to divide both sides by positive 9. So we're left with x is, and we bring down our sign, is less than or equal to negative 6. Let's go ahead and graph that on our number line. We know we have a closed circle on negative 6. And since this is less than or equal to, it's going to the left. So what we can do is we can go ahead and, to check our work, let's go ahead and rewrite our inequality here. Let's go ahead and substitute one of the values that's shaded. So let's try negative 7 to see if that works. So 9 times negative 7 gives us negative 63. That is definitely less than negative 54. So our inequality checks out. So now let's go ahead and try this last example here for this video. So this is where we're going to have to flip our inequality because we need to multiply both sides by negative 9. We know that our negative 9s cross out on the left to give us D. On the right-hand side here, we're given negative 36. And then we take our inequality sign and let's go ahead and flip it. So we're left with D is equal to negative 36. Let's go ahead and graph that on our number line. And our number line, let's go ahead and skip count by 9 here. So we're going to do negative 27 on the right, and let's go ahead and do negative 45 on the left. What that will do is that will give us a nice easy number to divide by. So when we compare it, when we check, we can compare whole numbers and we're not comparing decimals at all. But let's go ahead and graph this now. So we have open circle on negative 36 and our solutions are hanging out on the left-hand side of negative 36. Let's go ahead and check our work now. Let's go ahead and substitute our negative 45 on the left-hand side. So when we do negative 45 divided by negative 9 is a positive 5 is greater than 4. That inequality statement is true. So we know that we did our inequality correctly. So that's the only thing you really have to remember. It's exactly like one-step equations, except you're going to have a lot of solutions. And the biggest change is that if you multiply or divide, it's only for those two. When you multiply or divide by the negative number is when we flip around our inequality sign.